Hello everyone, we are group H20. Welcome to our group presentation for assessment task 3. In this study of assessment 1, our group studied the group of the disabled. Across our studies, people always touching the same objects in government places service New South Wales, which may increase the risk of transmission. During COVID-19, the government appealed to people to comply with public health rules. Our user group basis is refined into visually impaired people who go out to public government places, concerned about how to reduce the exposure of the visually impaired, how to reduce the risk of infection when necessary contact behavior happens. Our chosen user group is the blind people over 16 years old. There is a need to stay at Service New South Wales. Our design aim is to create a robotic assistant device that can help blind people reduce the risk of infection at Service New South Wales. Our vision is to enable the blind people to enjoy the advantage of true accessibility. 4 user requirements, divided into 4 parts. The first one is functionality. The system is obviously and clearly. Next is safety. It is necessary to ensure the safety of the user at all times. A vibration system should in the device reminds the user that an item is approaching quickly when the distance is very close. Then efficient. Users need to know quickly how they need to do, especially in special time. The device should run fast at saving time. Accuracy based on the disabled group. More perfect accuracy is needed to ensure the success of user operations. The accuracy of each system and the exact location of each touching. Here's the example picture of our chosen location, Service New South Wales.
For our conceptual solution idea is to help visually impaired people connect with the real world, to help them identify obstacles and reduce the risk of virus when they touch objects. People have visual sensor can know the location of the object and the environment, space information. But when visually impaired go out, they lack a visual feedback and sense security due to the lack of understanding of surrounding environment. And the device can help visually impaired people provide information about the surrounding through the touch and the hearing. And I have the conceptual solution video to show you. The voiceover in the accessibility function of iPhone is indispensable for visually impaired to use a mobile phone. But one of accessibility function software is called Magnify. When we turn on and open it, it is no different from ordinary camera interface. But when we turn on the voiceover again, you will see.
A black laptop on a white surface, a person standing in front of a group of trees under a cloudy sky, a cup of coffee on a table, a group of people walking on a sidewalk next to a group of buildings under a night sky, a hallway with white walls and a wooden floor, a person sitting at a table with a laptop and other objects on it, a white door next to a white door, a coffee machine and a cup on a table, a person wearing a hat and standing in a room.
In this software, the voiceover can identify not only the main body of the picture, but also the surrounding environment. When the main body of the picture is very complex, it even describes the object in more detail. More importantly, it sometimes describes the sense of picture. On the iPhone 12 Pro, it can also accurately measure the distance between you and the person in the camera. When somebody close to you, the phone vibrates fast, nodding you to avoid obstacles. This is a conceptual solution that we demonstrate to help visually impaired people reduce the risk of infection through such a feature.
For this iteration, I have added some features that I think would make the smart device more efficient and effective for the user. The features that have been added include the digital screen, Bluetooth on and off button, and the charging port and cable. For the appearance, I have designed the looks of the visual sensor. It will operate in 360 degrees. The location of the disinfection spray has been moved to the middle of the device, added a digital screen that can display the interface. Every button is designed consider effortless. As our user group are blind people, I wanted to make the button to be recognized by using only touch sensory, so it's easy for blind people to use.
Well, I still think that it needs to have more carrying width, things that the users may not suitable for just carrying the long graph. So maybe improve the graph to keep the touch is better. And it needs to have the only one eye contact switch, and all that can control with the voice control.
Here is iteration 3, which was divided by Evan is me. Based on the situation of blind people, I found some of them do not familiar with walking stick. They may use guide dog or wheelchair, so I gonna combine my idea from assessment too. Cause my Mr. Dog do not have the limitations. And the function of my development device is voice control. Digital screen can show the information to others like staff. Two versions of wear and the measurement device, and also the feature of the flexibility.
Glove style strap based on original prototype. A strap is added to the original design. It can be put on the hand for easy carrying, and the button can be touched by simply bending fingers. Alcohol spray is set around this device, covering a larger area. There are voice prompts for any operation for the blind people to use, and sports Bluetooth headset function.
For my smart device iteration, I made only a partial change, going from just one spare disinfectant to two, and chatbots in the rear, and changing the speaker form. Others remain the same as previous generation.
Think that all our users cannot see anything on their phone, so all the apps on the phone can control with the mobile phone wheel butler. And there's four things need to connect in this design: the mobile phone app, the Bluetooth earphones, and the production itself and the production carriers. In the mobile app part, you can connect with the internet to download some things, and it will recommend you all some popular things every month or every week. And you can try to add it to your own app or just download them but not add. And in the connection part, it can give you all the phones and all the smart drives that are around you. You can choose to connect which one. And in the app itself, you can try to add some screenshots you like to add. It will set about the speed of the search app and add to more things it can search. And moreover, the main switch is also on the phone. You can use this switch to open and close all those programs to run face some unjust situation. As I said before, all this act can be done with the phones itself, like Siri or things like that. So our users can download by themselves without saying anything. In this part, I'm going to talk about the Bluetooth and the control plug of the design itself. There's only a little thing to talk about the Bluetooth. Just connect with the camera on the design and to tell the users which is just around them and what is really important need to care about. The camera is connected with the high technology that can think about the main body of the picture and some more accepting actions in the picture, and it has a wide angle to see more objects in the film, and moreover it can catch some information if you are moving really fast and it was shaking up and down. The screen is not show for the users since they cannot see. It's to show the people also in the public around the users. The screen can connect with the shocking part to warn the user that there's some dangers around. It can also call the people around for help. And moreover, if there are some disturbed teams, it can also say sorry to the people around. Since our project is not very, it cannot think about all the information, so we think that ask people around for help in some special time is really useful. So we think design about the screen.
Next part is about the final prototype. Here is a different version of our smart device, which was made by Factorworks, and you can see the elevation and the 3D view about that. Now I will introduce some features and function of smart device. Smart device has automatic guide which can receive the instruct from blind users, and it will guide user to do some common activities in Service New South Wales by using Bluetooth and voice control. Before blind man use that, it can fit the height of blind user, which is user friendly. And the middle blue circle device is a distance measurement. It has the same technology as the iPhone, which has some sound and notice blind users. In addition, the digital screen can show some information to staff and other visitors, like emergency help, the number of visitors, and so on. Before blind man holds the smart device, the touching control will sense the human body temperature, and the safe belt will make sure the location of user hand. After use that, blind man can return smart device to return space, and the smart device will charge by USB. The more important thing is smart device also has two modes in the bottom of the device. The President will introduce the details.
For the view function, we use a 3D software called Maya to build and render some part out, as we wanted to present the model in 3D form, considering how it will look like in reality. For the view, there will be two different versions of it. The first version is a sphere. It is built with rubber and is in a round shape to ensure that the user will be safe if they get hit by the walking stick. Also, with this design, it will support blind people to do the certain activity easier. For example, when they need to do tasks that require them to push or touch the public facilities, such as opening the door or using the toilet, the sphere will help user not to fall down. The second version of the view is the active version, which is designed as two views. This design will support users when they are doing some certain activities, as it is flexible and convenient for the users. This graphic element presents how different sides display on the prototype's digital screen. The side will include an emergency sign, warning sign, disturbance sign, and the last sign will indicate the queuing number for guests in Service New South Wales.
This is physical mode based on 3D modeling and combines the previous assignment to work. The key with smart device, the two wheels are at the bottom to make it flexible.
According to the user's requirement, we made up this table to think about whether our design is successful. I think most of the parts is really a good design, but there are still some feedback need to check. In the function part, we own a very good feedback, so it is really successful. But we only think about some common situation, so this may face some danger if there are some special spaces, like if they are too noisy that the user cannot hear anything, if the user have the bad hearing too. Our design is fit the user's need and the user's requirement, so the user's need is successful, and the safety is really successful since that we some helpful connect with the people around.
and the effect is really easy to learn, and it costs a little technology, so we think it is successful. However, in the exported part, we think that we care a lot about the voice. I think we should care about more other things like touching, or smelling, not only hearing, I think.
We conduct an online survey with qualitative questions and send it to each member in the group. As our testing method, I test with ourselves. By simulating as the blind people, we will answer the questions by ourselves, considering the use of blind user in the actual scenario. The goal of this survey is to identify the problem and thinking forward on what part of the design has to be improved. The question will include 5 questions in total and are conducted in Google Form. We received some feedback on how to further improve our prototype device, including how to wear and carry, the improvement of vibration in the transmission function, and the detection system to be able to perform autonomous judgment and broadcasting from primary to secondary. By conducting this online survey, we are being able to improve the design features to be more effective.
In conclusion, our smart device have the potential to support visually impaired people when they go to public government service space, and to be more effective by improving user feedback. Steve Jobs once said, Apple's products are strong because they always stand at crossroads of liberal arts and technology. So our design vision is to allow the visually impaired people can go out freely and see the real world.